Hi Sir, Jan Sagapsapan. My name is Aikael. My topic is all about basic terminology and representation graph traversal algorithms of BFS and BFS. Definition graph, vertices and edges. Graph is one nonlinear data structure that consists of some nodes and their connected edges. The edges may be direct or undirected. The graph can be represented as G and BE. Definition: a graph G equals BE by defining a pair of sets. BE equals a set of vertices. E equals a set of edges. Each edge is defined by a pair of vertices. An edge connects the vertices that define it. In some cases, the vertices can be the same. Vertices, also called nodes, denote vertices with tables, and there is examples. Type of graph. Number 1, null graph. A graph is known as null graph if there are no edges in the graph. Number 2, trivial graph. A graph having only a single vertex. It is also the smallest graph position. Mao na ang iyang example. Null graph and trivial graph. Ang trivial graph ay isa ra siya ka node. Dayon ang null graph ay upat siya ka nodes na wala siya edges. Number 3, undirected graph. A graph in which edges do not have any direction. That is, the nodes are unordered pairs in the definition of every edge. And number 4, directed graph. A graph in which edge has directed, that is, the nodes are ordered pairs in the definition of every edge. Ano yung example? Undirected graph, connect siya tanan. Then, directed graph with connect siya pero with arrow. Ang 5.23 and 3.1, 1 to 5.24 with arrow. Number 5, connected graph. The graph in which from one node we can visit any other node in the graph is known as connected graph. Number 6, disconnected graph. The graph in which at least one node is not reachable from a node is known as disconnected graph. Ano yung example? Connected graph, connect siya tanan dayon. Disconnected graph with one pair lang siya. With, ang disconnected graph node is not reachable from one node. Muna siya. Okay, number 7, regular graph. The graph in which the degree of every vertex is equal to k is called k-regular graph. Number 8, complete graph. The graph in which from each node there is an edge to each other node. Ano siya yung example? To regular graph, connect siya regular. Complete graph is connect siya tanan with kan tapos siya connect sa 3 to 4 then 5 to 1. Representation of graphs. There are two ways to store a graph: adjacency matrix and adjacency list. Representation. Represent vertices with circles, perhaps containing a label. Represent represent edges with lines between circles. Adjacency matrix. In this method, the graph is stored in the form of the 2D matrix where rows and columns denote vertices. Each entry in the matrix represents the width of the edge between those vertices. Here an example. Adjacent matrix of graph. 0 to 0 equals 0. 0 to 1 equals 1. Kay 0 to 1, i-connect man siya ni 1. Unang 1 siya. 0 to 2, 1. 0 to 3, 0. Kaya wasa ni-connect ni 3. 1 to 0, 1. Kaya 1 i-connect ni 0. 1 to 1, 0. 1 to 2, 1. Kaya i-connect siya ni ang 1 i-connect siya ni 2. Then 1 to 0, wala siya ni-connect ni 3, manang 0 siya. So, dayon lang taman sa mahuman mo nang 0, 1, 2, 3 ang iyang kan. So, yun na kaya siya i-connect. Oh. Adjacency list. This graph is represented as a collection of linked lists. There is an array of pointers which points to be edges connected to that vertex. Og mo po na yung example sa adjacency list of graph. So natay 0, 1, 2, 3. Dayon si 0 yarang isulat diri sa iyang pikas arrow ang iyang gikonikan. Pangitan 0, connection ni 1, connection ni 2. Si 1 ni connect ra ni siya ni 0 ug ni 2. Si 2 ni connect ni 0, ni 1 ug ni 3. Si 3 ni connect ra siya ni 2. Mora siya ang pag-collect sa adjacency list. Next, traversal algorithm. Breadth first search (BFS). The breadth first search (BFS) traversal is an algorithm which is used to visit all of the nodes of a given graph. In this traversal algorithm, one node is selected and then all of the adjacency nodes are visited one by one. After completing all of the adjacency vertices, it moves further to check another vertices and check its adjacent vertices again. Dire na ta sa BFS. So ang BFS kay mo ni siya yang sample. Print A and insert its child nodes into the queue o key. Ang yang di kuanan si A mo is a root node. Then yang insert ang iyang child nodes bali si B o C. Dayon sa print B and insert its child nodes into a queue gyapon. Si B o si A yang gikunikan si B. Dayon si C. Then abot sa print B, si C iyak kunikan si D og si E. Og dira pud sa print C and insert the child nodes into the queue. Si D yang gikunikan si E, dayon hinlahos siya sa ni F, dayon nilahos pa siya ni G. Og maura na taman sa mahuman ang iyang algorithm na pagkuan sa array para sa address sa kuang right nga unsaon siya pag-connect. Mao na siya ang BFS. O diritan sa sunod sa DFS, depth first search. The depth first search DFS is a graph traversal algorithm. In this algorithm, one starting vertex is given, and when adjacency vertex is found, it moves to the adjacency vertex first and try to traverse in the same manner. O mao po na yung example sa pag-connect sa DFS. So, na siya pagkuan sa array sa pag-connect niya kung saan siya pagkuan sa yung algorithm pagkimo o pag-connect sa yung array. So, magsugod siya ni root node ni A, padung siya ni B, si B ni adto ni D, dayon si D ni balik siya ni B kay deep first search man siya, so iya sang adto ng kinailangan aya siya mo balik sa taas. So hiadto si A mo man siya root node, niadto siya ni B og ni D kay iya mang kuan, iya mang child din mo kun siya ang iyang deep. So ang D iyang deep kay si A mo balik siya ni B, so balik na po siya ni A, ahya na po siya mo deep na po. So mangita na po siya laing kuan ning array kung sa right nga array kay human naman siya sa left nga array. So dire na po siya ni C, then ni F, then si F padung ni C kay human naman si C deep ni F, moangat na po si F si C sa C, dayon si G na po kay napamayan siya right array, then balik na po siya ni C. Okay, sorry, ni C, dayon ni E na dayon. So ina siya na lang siya pag kuan sa deep first search. So thank you, o mora to ako ang report.